This is Tier 1 Lesson 3, Exponential Growth. The general form of an exponential function is this f of x equals a times b to the x power. So this is the form we've been kind of looking at in the transformations. We said b was 2. So where x is your input, f of x is your output, a is going to be your initial value, or your starting value. I'm going to say initial. Okay, and b is your growth factor. So if we look at a table, we start with our a, and as we plug in 1, that means a times b to the first, right? So if we plug in 1, we have a times b. If we plug in 2, we have a times b squared, which is a times b times b. You see how we're multiplying by the same thing every time? When we plug in 3, we have a times b times b times b, which was just the last one, times another b. So to find the growth factor, it's really easy in the function 1.02. To find it in the table, we need to figure out what we're multiplying by. So what are we multiplying by to get to the second row? Well, we could find that from division. So I'm going to take my values, 5,306.04, and I'm going to divide it to go backwards, right? If we multiply it to go down our table, we divide to go back up our table. So 1.02. I could do that with any of those values. Right, there it is again. And we want an approximate. There it is every single time. So think about it, we have 5,000. That was our initial value times 1.02 gives us our next value times 1.02 gives us our next value, gives us our next value. We could keep doing that and going on if we had more table. So you can see that 1.02 in this equation, and our 5,000 is our starting value, fx equals 0. And we found it in here. 5,000 times 1.02 gives us 5,100 times 1.02. It's a common multiplier. And you can see what this equation is going to look like. You see at x equals 0, we have 5,000. And we're going to get that exponential shape that we had from the other ones. Okay, it's a little hard to see because of the scale that I did, but if you'll see that it's increasing exponentially.